Okay, next lesson. You have to solve this equation. It don't look like much, but one thing you have to recognize, and you're solving for x, okay? This doesn't mean 5 times x. A lot of people think it's 5 times x, so they're like, well, I'll just divide it by 5, okay? No, it's not quite that simple. It's not 5 times x, it's 5 to the power of x. So what I like my students to do is to make an upside down v, and that kind of tells you that that's a power, okay? So you can't just solve it by dividing. So if I have to solve for x and x is in the exponent, I would personally parenthesize the exponent, put that in its own parentheses, and parenthesize the base of the exponent, 5, okay? Now, the next thing I'm going to do is just, the x is the exponent, okay? So I just put x equals, and I know I kind of already wrote that there, but you'll see why I'm writing that here in the next problems that come up. So I just start it and figure out how many 5s does it take to multiply it, and you're like, why did you just make that? Well, you're going to see here in a second. My first plan is to figure out how many 5s it takes to multiply to 625. So 1 wouldn't do the job. That would take me to 25. Remember, I'm trying to get this equal to 625. Okay, that's what you're trying to do. 3, well, again, now, and you start ending up with somewhere you're going to want to use your calculator. Well, that's not 625. So I times by another 5. And you're at 625. So, okay, how many 5s was that? It was 4, so x equals 4. And that is our answer right there. Okay, now in the next problem, again, we're solving for x. But again, I see that x is a power, so I put the upside down v, and then we want to parenthesize the power, the 2x, and the 25. Now, the power is 2 times x now. So what I'm going to do is write 2x over here, unlike the last problem where I just wrote x. Okay? And I've got 2 ways I can go. The first way is to figure out how many 25s it would take to multiply to 125. Okay? So 25, no, let's times by 25 again. No, I went over the 25. Once you go over it, you can't come back. So that plan does not work. Okay? So if that plan fails, what you're going to do instead is use your log divided by log, because it's going to be a decimal. It's an irrational decimal, which we will round. Okay? And then I put the 2 parentheses. Now, one thing you have to get right. Whatever's the base of the exponent, 25, that has to go on the bottom. You can't flip it, okay? Whatever's the base of the exponent, that's going to go on the bottom. And then 125 goes on top. So on my calculator, I'm going to have to use my calculator, so I take log 125 and close the parentheses. Then I hit divided by log 25 and I close the parentheses. It gives me 1.5. But don't put that here. You put that right here. And then to solve for the actual x, you need to divide by 2. Okay? So 1.5 divided by 2. 0.75. Okay? And that's your answer. Okay, the next problem. Again, here's my x. Again, x is the power. Okay, so I'm solving an exponential equation. Finding where the variable I'm trying to figure out is in the exponent. So I put a parenthesis with the 3, parentheses with the x. Okay. And then the exponent is just x. See, here it was 2x, so I wrote 2x equals, but here it's just x, so I write x equals. Okay, now remember there's 2 ways to do this. The most logical way is to figure out how many 3's it takes to multiply to 36, okay, because that's what a power is. So 3 times 3, that's 9 times 3, that's going to be 27, times 3 again. Okay, I'm over 36, so that way will not work. It's a decimal. So to find what the decimal is, I use my log over log. It's called the change of base formula. COB, change of base. So when I say change of base, it's like log over log. So remember that 3 has to go on the bottom and 36 to the top. Okay, 3.26, just round 2 decimal places when it's an irrational decimal. I don't have to do anything else. Okay, 3.26 is my answer. Okay, my next problem, solving for the x. So again, I make the v, I parenthesize the exponent and the base. Okay, so the exponent is x minus 3 this time. Okay, so there's 2 ways to do this. One is to try to multiply 7's, factors of 7 repeatedly to get to 25. Okay, that's 49, so that won't work. So we have to do the change of base formula. Okay, so remember, put the 7 in the denominator, 25 in the numerator. So log 25 divided by log 7. 1.65, but again, now I have to get the x by itself because the exponent had x minus 3. So I would have to add a 3 to both sides, and that's 4.65. Okay, next problem. Again, when I recognize that, okay, it's not 5 times x, it's 5 to the power of x, okay? So I parenthesize the power and the base. Now, right now, you have a plus 3 in operation here you have to cancel out before you start worrying about how to solve for the exponent, okay? See here, I was pretty much ready to go. Here I take that x equals, but before I worry about the power, I need to get the plus 3 out of there. So I need to subtract 3, and that's 9. So now it's 5 to the x power, and then just reset your parentheses up. So you had to do a little thing before that. And now you can figure out what your exponent equals. So first 5 to 9, I don't think that's going to work. So 1, okay, that's too high, so that won't work. So I have to go to my change of base formula. So 5 goes on bottom, 9 goes on top. It's a decimal, okay? So log 9 divided by log 5. Okay, 1.37. If there's a 5 or greater in the third decimal place, round it up. 1.37. And problem solved. Okay, I have solved for the x. Okay, next problem. Again, go find your x. It's in the power, so I make the v, parenthesize the exponent, and the base. One thing you can't do, you can't take 2 times 10. A lot of people do that. Okay, when the 2 has no exponent and the 10 has an exponent, you can't multiply them. So don't try to pull that trick off. Okay, so I need to solve for my exponent, which is 2x plus 1. Now, before I worry about solving for the exponent, I have to undo the times 2. So it's 2 times. The opposite of times 2 is divide by 2. And that takes me to 15. And then we got 10, and then 2x plus 1. So I reset up my parentheses, and now I'm ready to go. Everything outside the parentheses is gone. If you have an operation outside the parentheses, you have to undo it before you come down here. Okay, so let's try to multiply 10s to get to 15. We probably know that's not going to work, but there's 1, that's 100, so that isn't going to work. That plan fails. The change of base always works, okay? And 10 to the bottom, 15 to the top. Don't flip them, okay? The base of the power goes on the bottom. So I take the log of 15 divided by the log of 10, and I get 1.18. But that isn't the answer, because now I have to solve a basic linear equation for x. Subtract 1. going to be 0.18 divided by 2. That is going to be 0.09. Okay. Okay, next problem. So again, here's my x. It's a power, so I parenthesize the whole power in the base. Okay. Now you have an operation outside, so you got times 5, so you're going to have to divide both sides of that equation by 5. Okay. And that takes us to 100. So I go 3. And then over here I just rewrite the same thing. I set up my parentheses, and now I'm good to go. Okay. Oh yeah, by the way, right away I should have wrote 2x minus 3. That's my bad. So equals 100. Let's try to multiply 3's. Okay. So 1, that's 9. That's 27. It's 81. And that's going to go over the 100. Okay. Okay, yeah. So again, we have to apply our change of base formula. Okay, so 3 on bottom, and then 100 on the top, okay? Because the 2x minus 3 is over here, okay? We're just right here, we're trying to figure out what I could set that equal to. So log 100 divided by log 3, 4.19. Then I will add the 3, that's 7.19. And divide by 2. 3.60. Okay, last one. So here's the x. So the power is just x. And then I parenthesize my base. Now outside the parentheses you have a times 10, so before you worry about anything else, you need to divide both sides by the 10. So that is going to be 100. And now I can apply my rules. First off, see if you can multiply 4's to get to 100. 16. That's 64. And 64 times 4 then is going to be 256. So that doesn't work. Okay. So I go log. Okay, so 4 on bottom, 100 on the top. Okay. I'm actually going to do number 1 on the assignment with you. So 3.32, and that is going to be our estimated answer. Okay, actually I'll do number 2 with you. Okay, that's good. Number 3, sorry, I can't make up my mind. Okay. Alright, so power. Now over here we were solving for x at the end, but first I have to solve for the 3x. Okay. There's no operations outside, so we come straight down here. Now let's see if we can multiply 4's to get a product of 64. Nothing but 4's. So 1, 2, 3. Maybe that works. Good, 64. So I don't need to go over here, okay? So how many 4's did that take? 1, 2, 3. Okay, so 3, and then I divide by 3, and x is 1. Okay, so don't just fall in love doing the log over log every time, the change of base. Okay, if you're able to multiply that base out to hit 64, then there'd be 3 of them, 1, 2, 3. So then you can put 3 without having to do the log over log.